All right. Well, we'll go ahead and get started. Thank you, everyone, for your time today to join us for our TechCrunch and Lunch presentation. My name is Isaac Liu, and I'm a local client manager for Optiv Security. If you haven't worked with us before, we are one of the largest cybersecurity integrators in North America. Our main mission is to help our clients maximize and communicate the effectiveness of their security program, whether it's to solve a particular challenge or to deliver a certain business outcome. And today, Optiv is excited to share with you 3 featured modern cloud security vendors. First, we'll hear from BitGlass, a next-gen CASB helping customers ensure data security and regulatory compliance. Next, we'll hear from Cloudflare, a SaaS-based security provider that provides services such as WAF, DDoS mitigation, bot management, and more. And finally, we'll hear from Sumo Logic, a cloud-native continuous intelligence platform. With any time remaining, I'll field a few questions and wrap up on how you'll receive your DoorDash code. And again, this is intended to be a very casual event, so please submit any questions in the Q&A form down below, and we'll attempt to respond in real time or follow up separately. So without further ado, I'll pass control to our first presenter, Jacob.
Hey there, thank you. Just gonna share my screen here. All right, so hi everybody. Good to be with you. Again, my name is Jacob. I'm a senior PMM at BitGlass, and today I'm going to be talking about how CASBs like BitGlass can help you secure your use of cloud and BYOD, as well as ensure remote security. So we'll just start with a general kind of problem slide where the idea is, once upon a time, everything was on premises. Your apps, your data, your user, their devices, everything was behind the perimeter, and it was easy to use these standard technologies like firewalls to really feel safe and secure, and like you had control over everything that was happening in your perimeter on premises. But as data has moved off premises into a variety of applications and devices, it has really challenged the use of these tools. They're still necessary, but they're no longer sufficient in and of themselves. And so on the right side here, you can see a couple of different types of applications and devices. And so managed applications, those are the apps that are officially deployed as a part of your IT ecosystem in your organization. And these are typically the major SaaS applications like Office 365 as an example. And so as your employees are using those day in and day out to perform their work duties, most of your data is going there. And that means that it's your primary responsibility to secure those managed applications. Now, once you have secured them, you then want to move on to secure these unmanaged applications where they're a little bit more niche. Sometimes they're more the long tail of SaaS, if you will. Some of them may just be time wasters, but some of them might basically be enterprise file sync and share, like a Dropbox or something like that. And your employees may use them to leak data, whether intentionally or unintentionally. And so these shadow IT apps, while not as much data can move to them in a day in, day out basis as your managed applications, you do still want to secure them. Now on the bottom, you have those 2 different types of devices, managed and unmanaged. And again, just to continue to set the stage here, these managed devices are corporate assets. And what that means is they are the property of your company. So you can secure them however you like. You can put agents on them. You can, exercise control however you want. Now, that does make it a bit easier to secure them, but as they move off premises and you have remote workers, it still does increase the challenge somewhat. But the real challenge comes with securing personal or unmanaged endpoints. This refers to BYOD, or bring your own device, where you have countless users accessing corporate IT systems from their personal phones. And that represents quite a bit of a challenge. So the question becomes, as data moves into these different apps, as data moves into these different devices, and you can't do things like go put a firewall around Microsoft to secure Office 365 as an example. The question is, how do you protect your data? And that's where CASBs come into the picture. And so this is what BitGlass is. We are a cloud access security broker. And here you can see just a very high level overview of the 4 pillars of CASB. So that's data protection, which has things like encryption, cloud DLP, threat protection, which contains capabilities related to ATP, as well as the ability to detect insider threats through things like user and entity behavior analytics. You also have visibility, the ability to maintain oversight wherever your data goes through things like activity logs that clearly lay forth what all of your files and users and apps are up to. And then last but not least, identity, which is really the cornerstone of solid security when we think about the cloud and remote workers and BYOD, because you have to know who is who and authorize people in order to apply contextual granular protections. So here for identity, you'd have things like single sign-on or multi-factor authentication. And so CASBs are really multifaceted solutions, and I'm mainly going to be focusing in on that top left quadrant and a couple of tools there and how they can help you secure your cloud, your BYOD, and remote workers. But before I do, I want to spend a little bit of time on architecture. I'm not going to go too deep, not going to get too nerdy here, but it's important to have a general understanding of CASB architecture so that you can know how to solve different use cases, as well as what kind of CASB your organization should look at when it's faced with something like this now basically entirely remote workforce. So here's a solution architecture of a multi-mode CASB. And as the name implies, it means that it has multiple deployment modes. There are different options you can use from an architecture perspective, and each one meets a different set of use cases. So I'm going to go through these one at a time. And the first is API. That's application programming interfaces. And the idea is API is like a connection or a port on an app. And CASBs are able to plug in and to integrate with those, and by so doing, get visibility and control over the data that is at rest inside of those applications. And so that's helpful for things like detecting sensitive data patterns inside of files in, we'll say Workday or Box or whatever you might be using, and then applying DLP for data at rest inside of those applications. But you can also do things like identify malware and bolster native sharing controls to do things like remove shares from public parties. But a couple of problems with this API approach. One is not every application has an API. So if you pick a CASB that only has API integrations, you're automatically limiting yourself from securing the vast majority of applications. But the second issue is that it takes time to crawl applications and to crawl the data at rest within them. So it's inherently out of band. It's not real time and it's not inline security. So API integrations are useful for protecting data at rest, absolutely, but not so much when we try to think about real time security. So that's where proxies come in. And proxying traffic just basically means you are doing just that. You're proxying traffic. You're in line, and as you are in line and you're monitoring traffic in real time, you're able to apply those real-time protections that you want. So the first kind of proxy is a forward proxy. These are basically agents, software that is installed on a user's endpoint. And because it's on the endpoint, it is basically in the flow of traffic and gives you full visibility and control over everything that's happening on that device and everything moving to and from that device from a traffic perspective. So you do get the real-time DLP, you get the real-time visibility and all those kinds of things, but it also has a unique set of use cases around controlling unmanaged applications. So do you want to block certain apps or categories of apps? Do you want to allow them? Do you want to coach users to sanctioned alternatives? Do you want to render apps read-only so that they can access them but not leak data? So it does have its unique set of use cases. The issue is that when you put a forward proxy on a device, you're getting full visibility and control, like I said, over everything that's happening on that device. And so that might be okay for managed endpoints, but when we think about personal devices, employees don't always want to feel like Big Brother is looking over their shoulder, for lack of a better way to put it. And so you need something that isn't going to scrutinize all traffic and all activity on the device in order to protect data while simultaneously respecting user privacy and having a solution that will be easily deployable. So that's where reverse proxy comes in. And reverse proxies are deployed in the cloud rather than on the device. And the way that they work is they proxy traffic to and from your managed applications. So there are no agents involved. It's deployed in the cloud, and consequently, you're only proxying managed app traffic, so user privacy is respected. And so that makes it easier for deployments, but it also makes it easier for deployments from the perspective of getting your hands on devices and putting agents onto them. So whether we're talking about personal devices or remote devices, reverse proxy is critical. So when you're looking at CASBs, make sure that you select a true multi-mode CASB that has all of these deployment options, not just one or two. But in particular, the one that you really want, given the current state of affairs, is the reverse proxy. So with that in mind now, I'm going to go ahead and jump into those two tools that I mentioned previously in terms of data protection and how it applies to securing cloud, BYOD, and remote workers. Because while it may sound like these are different issues, they are all inevitably quite intertwined. So first couple of bullets here are definitional, and I've already covered them for the most part. So you have managed apps and unmanaged managed devices and unmanaged devices. So company-owned versus personal, and different devices require different approaches to security, like I mentioned with forward and reverse proxy, with agent versus agentless. So for agent-based solutions, once again, putting something on the device, that's okay for managed endpoints, especially as they are on premises. But when we have data moving and devices moving off premises and people accessing data from personal endpoints, that's when you really need to make sure you have this agentless solution, which, as I mentioned, is a CASB with a reverse proxy. So assuming you have all that established, the two tools that I'm going to talk about briefly are real-time cloud DLP and contextual access control. So when we think about cloud DLP, it's really an umbrella term, data loss prevention, and it refers to a number of capabilities that are designed to provide varied levels of data access. So one example would be redaction. Let's say you have a user who tries to send some sensitive data pattern in plain text in the body of an email. Well, as the CASB is in line, it's going to detect that in transit, and if you have a policy configured, it will automatically redact that, meaning that maybe it's a social security number. That social security number is effectively removed from the email and replaced with a string of X's. So the recipient, when they open it, they don't see a social security number, they see a bunch of X's, and when the sender goes and looks at it, same thing for them. So that's one, but another would be DRM, or digital rights management. So in this example, let's say that you have some really sensitive file type, and maybe you have a policy set up that says when anybody tries to download this, or some specific group, or someone who doesn't meet a specific criteria, regardless, when they try to access this file that's very sensitive, they're going to download a wrapped or DRM'd version of that file. And what that means is when they go to open it, they are redirected to a password protected portal online where they have to input credentials to demonstrate that they are in fact authorized to view that file. And even then, it's just a read-only version of the file. So you preserve data integrity simultaneously. So those are a couple of examples of DLP. Those are my personal favorites. But the next tool is contextual access control. And this really goes hand in hand with DLP. And as the name implies, you are controlling access to apps, files, different systems that you might have based on the context of a user. And you can do this by a number of variables. So where are they located? Maybe we just want to allow certain regions. Maybe we just want to block certain regions. What kind of device are they coming in on? Is it a managed device or a desktop? Well, maybe we want to give them higher privileges, but maybe we want to block mobile or personal devices on certain applications. You can also do it by custom factors that you might choose to set up. So these are really granular capabilities. Now, the last bullet here is polyscale architecture, and this is how we describe BitGlass's architecture. And the general idea is, once again, you want to make sure that you have something that is fully deployed in the cloud when it comes to a CASB, because if you rely upon something that isn't cloud deployed or requires an appliance on premises and moving traffic to that appliance in real time, it can create some lag in user experience and can create some bottlenecks and some issues that way. So again, make sure that the solution is fully deployed in the cloud and that it scales to the needs and the exact IT footprint of your organization. And everyone may be remote right now, but eventually everyone's going to be back to normal, and you're going to have things like SKOs and offsites where you'll have upsurges and higher demands on certain data centers. So that's a little bit of oversight on how to secure cloud, BYOD, and remote workers. And to just wrap us up, I have just a couple minutes here. I want to talk about a real BitGlass customer who uses our CASB to protect data, to put some flesh and blood on this. So this is John Muir Health. They're a leading healthcare system in the Bay Area. They have thousands of physicians and office workers and these kinds of things. And they migrated to Office 365 but found fairly quickly that the native security functionality was a bit lacking for them, didn't have the granularity that they wanted, especially as it related to protecting protected health information from unmanaged devices in particular, because doctors tend to carry their personal endpoints with them and to perform work from those. So they tried agent-based tools, first-gen CASBs, things like mobile device management, and found that because of the whole agent thing, they had a hard time deploying them on remote and personal devices. So they came to BitGlass because of our agentless architecture and the fact that we can secure any device as it accesses any application, and we can apply granular policies wherever data goes without the need for an agent. Once again, because of our agentless deployment option, it was a rapid rollout for them. It took days to weeks rather than months to a full year or something like that. And we are now still in line for them and enforcing real-time DLP policies to protect their data as their doctors move from hospital to hospital to hospital. So that does it for me. We have our website and our handle on social media here. So thank you so much for your time.
Awesome. Thank you very much, Jacob. Just a moment while I share my screen. Okay, perfect. So thank you everyone for allowing me to have about 50 minutes to talk about Cloudflare today. My name is Michael Clemente, and I'm currently a solution engineer at Cloudflare, and I'm leading the Americas Solutions team. So before we dive into Cloudflare, I think just to set the scene, I think we can all agree that the internet is critical for any business. And if anything, nowadays, with the horrible experience we're going through with COVID-19, that has become ever more true. We're all connected remotely to this conference call, and in businesses that have had online applications or did invest on their online status are definitely faring better compared to those that didn't. And we've had a lot of new challenges come up recently, especially with all the workforce and all of us having to work from home. However, there's something to keep in mind. When the internet started, it was pretty simple. You would just have some hardware, hook it in, deploy your website or whatever you're doing online, and the internet was a nice place to participate and be part of. Nowadays, though, things have changed considerably, and it's actually quite a scary place. First of all, we need to secure our applications, be it our internal applications, which users are accessing via VPN, or maybe we're hosting an e-commerce application. There will be people trying to get into our apps and exfiltrate data, or try to even simply bring them down to cause some damage to the business. Ransom notes, for example, is something that is pretty common nowadays for anyone operating online. But our users are also very demanding. We may have our applications hosted in a specific region, for example, in the US, and our users may be online elsewhere on the other side of the globe. And they expect the applications to be responsive, to be fast, and to be able to interact with them without any issues. And then there's an expectation nowadays that things are always online and always working. So hopefully most of you listening today already have some sort of disaster recovery strategy or have some reliability inbuilt in all of the online applications that you might be managing. How were these problems historically solved? And I'm talking again about security, performance, reliability. Well, over the course of the various years and the growth and the history of the internet, a lot of vendors have come up with hardware boxes. These hardware boxes would normally be placed in front of your application stack. So you may have your servers somewhere running your applications and your databases, and then you'd have some boxes on top of the rack, which would be performing a set of edge functions to make sure your application is operating correctly. And I'm talking about things like firewalls, load balancers, routers, VPN devices, et cetera, et cetera, et cetera. These boxes, though, over time tend to be expensive. You need to put up front a substantial investment to get them installed. They all operate slightly differently, so it's difficult to have a uniform environment across your entire network infrastructure. And every now and again, you'll need to replace them. But then they also have another issue, which is the fact it's difficult to scale them. If you buy a specific box to perform a function, you may, and you have a surge in traffic, your current infrastructure may not be able to withstand that traffic. Additionally, more recently, we have, and I think we can all agree, a lot of applications are being moved to the cloud. And this creates actually another dimension of complexity, because you cannot simply move your boxes to cloud infrastructure. There's no way for you to ship a application, a device to Amazon and ask them to install it in front of your EC2 instances, for example. And we're also relying a lot more on software as a service applications, e.g. to just name one. I'm sure a lot of you are familiar with Salesforce. It's difficult to manage Salesforce, right? Or to put your security policies in front of Salesforce. So we found that there's a need for a way to solve all these problems, to have that single platform, that single security layer and performance layer, but is trying to integrate all these different functions in a single application, and to be able to deploy that across of all of your segmented infrastructure, wherever that might be, on-premise, public, hybrid, or even in front of, in theory, SaaS applications. So you can have a single stance where you define all of your rules and your performance features. And this is where we come in. So historically, Cloudflare's mission has always been to build a better internet. In fact, when it first got founded, the idea was to provide features which would replicate those hardware devices, which are normally very expensive, and give those features to the masses. I'm not sure if any of you have been on our website, but we do offer some self-service plans, and that's where the company started, was with self-service plans. And I actually think we have one of the best free plan available on the market nowadays. And we were providing firewall features, CDN, performance, and similar to anyone who could not historically afford to put up front a large budget. Now, that mission stays true today. We're always trying to put forward the latest and greatest network implementations, technologies, etc., and just to provide them to everyone from our platform. Now, how does it work? Technically, Cloudflare is, for many cases, a very large reverse proxy. And we were talking about reverse proxy just in the previous presentation. So you would deploy Cloudflare in front of your infrastructure, be it on-premise, cloud, SaaS, or other. As long as Cloudflare speaks the same protocol that your end users speak, normally connecting to your applications, you're good to go. We can slice ourselves in the middle and provide our services. If it's a real user trying to connect to your application and they're going via Cloudflare, that's good news. They will get a better experience. It's going to be faster. It's going to be secure. If it's a crawler or a bot, for example, depending if it's a good bot or a bad bot, we may decide to let it through, or we may decide to block it. And that's those are controls that you are able to configure directly from the Cloudflare dashboard. And if it's an attacker trying to connect to your application, be it a volumetric attack trying to bring you down, or a hacker trying to infiltrate your application, of course, we have tools and features in there provided for you to detect those attackers and stop them at the edge, so they never get to connect to your application in the first place. The deployment model for Cloudflare is reasonably straightforward. We actually have various deployment models available. The standard one, though, is a simple DNS change. Normally, applications are routed by using host names and DNS. You simply get your domain name, bring it over to the Cloudflare platform, change your authoritative name service to be provided by Cloudflare. And then when your users are accessing your application, instead of resolving to the IP address of your application, they would resolve automatically to a Cloudflare IP address instead. So the traffic comes to us, and then we would proxy that traffic, if it's a good idea to proxy that traffic, back to your origin server necessary, wherever that might be. The proxy itself is providing a very large network. This is a pretty impressive network diagram that I always like showing. The proxy is implemented. We have actually shipped our own devices and implemented a proxy in over 200 cities worldwide. And we're currently supporting upwards of 26 million applications proxying on our platform. Now, the interesting thing to note is that every Cloudflare device out there, which is part of our cloud infrastructure, is actually anycasted. What I mean by that is that they're all advertising the same IP addresses. So wherever the end user might be, they will be automatically routed to the closest point of presence based on their location before we proxy that traffic wherever the origin is. If that origin is in the US, but the user is in Sydney, for example, the user will connect to our Sydney point of presence, and then we would proxy that back to the United States of America. And then finally, the other good advantage is because we were built initially, and our mission was to help build a better internet, and we were built for self-service users, the platform is a pleasure to use. It's very simple. The interface is very uniform, it's well designed, allows you to perform very powerful changes to your infrastructure just with a few clicks. But the interface itself, and I think this is the main point, is built on our own API. So you could actually replicate the entire interface by building on top of our API. So if you need to programmatically deploy configuration changes across your network infrastructure on Cloudflare, you can do that without ever actually logging into the interface in the first place. Now, I wanted to talk a little about the sort of features we provide and why the fact that we have a very large network with a large user base is useful for the Cloudflare use case. Now, as I said, the three pillars we're trying to solve here is performance, security, and reliability. Talking about the performance side of things, having good performance on the internet nowadays is very difficult, especially now with the traffic surges we've seen. For example, I heard Netflix has actually had to reduce the video quality across Europe because of traffic congestion. Being able to deliver good performance to any users, regardless of what devices they're using, is very difficult. But given we have all these applications on the proxy, we can actually monitor the state of the internet. And whenever we see traffic congestions with specific internet service providers or on specific hops, by leveraging some of our smart routing technology, we can actually route traffic via alternative paths, hopping towards via some other Cloudflare points of presence, avoiding any congestion there might be on the public internet, creating a better performance for your dynamic traffic. At the same time, having a large network helps us for the security services we provide. For example, our web application firewall. Whenever we see a new attack vector being triggered against one of our customers, we normally implement and deploy those mitigations, not only for that specific customer, but across the entire customer suite we have. So everyone is protecting and is benefiting from the wider customer base Cloudflare has. And the same applies for bot mitigation, for example, where for every IP address we see, and we believe we see pretty much any IP address connected to the internet nowadays, we're able to assign a threat score. And that intelligence is then provided back to you as a network admin or as an application developer via our interface to make smart decisions about challenging a specific request, maybe with a captcha challenge, blocking it, or maybe just letting it through if that's what you decide. The other important thing, and this is a little more recent over the last couple of years at Cloudflare, is we've built this very large proxy that you can leverage to your advantage. We're also opening up that proxy for you to build applications on it. You may have heard words such as serverless or edge computing. We believe we're at the forefront of those buzzwords, if I were to put it that way. But we've opened our servers. You can actually now deploy, for example, JavaScript on every single server we have without even having to think about where it's being deployed. You just submit the JavaScript via the dashboard or via the API. It gets deployed, and that logic will run on all of the traffic you see from your users. And it will scale infinitely without you having to worry about deploying new hardware, of course. And then, as I said earlier, our APIs are also, our own interface is built on our APIs. So not only you can build your custom logic, but you can integrate the Cloudflare behavior with whatever backend logic you may be wanting to implement. So for example, if you wish to change the security stance of the Cloudflare Edge based on something you're observing on the backend, it's very simple to trigger an API change and to get that deployed. Another common use case is if you're a publishing application and you're wanting to cache assets on the Cloudflare Edge, but every time some user edits the content or publishes a new version, you're able to programmatically refresh the cache or push a new version to the Cloudflare Edge by integrating with our API. Now, those are just a small set of features I mentioned. The Cloudflare portfolio has grown incredibly. And as I said earlier, we're trying to aggregate all those services into a single platform. Just to mention a few in the various pillars I've mentioned today, we have firewall functionality, bot mitigation. We're actually very well known for our DDoS mitigation, which I haven't talked about today. Rate limiting, but moving to the performance side of things, again, caching is very used on Cloudflare, as well as intelligent routing, dynamic content acceleration. But we're also able to optimize images and content, which is especially important for users on mobile devices or less powerful devices. And In the reliability pillar, at the edge, we're able to make smart decisions based on where you want us to route the traffic. We're able to do local load balancing. So you could actually get rid of those ELBs and just use the Cloudflare load balancer in front of Amazon, for example, and switch between your EC2 with health checks and failover. But we're also able to geo-route across different regions, actually in a better way because we're closer to the end user. So if you have for example, Amazon instances running in Europe and in the US, Cloudflare at the edge is able to direct the user to the right location based on where they are. We also provide what I think is one of the best DNS services there is out there. We provide it as an authoritative DNS server, but you may have heard of our public resolver. I'm pretty sure most people have heard of Google's 8.8.8.8. We managed to acquire the 1.1.1.1 IP address, which essentially is the same thing, except we promise additional performance and security and privacy along with it. And then at the bottom, you can see the platform, which is what I mentioned earlier, which is where you're able to build on top of the Cloudflare network. Last two slides for me. One other space we're moving into is, of course, given we're a proxy and we sit in front of your applications, and similar concepts to what we were talking about earlier, we've seen customers starting to micro-segment their internal networks as well, using the Cloudflare proxy as a shield across their different micro-segmented networks. And Cloudflare is now also able to perform authentication at the edge, optionally integrating with your identity provider. So we've seen customers actually adopt Cloudflare as part of their strategy towards a zero trust network or policy implementation. And this is becoming a use case which is used ever more often. Final slide about a use case with one of our customers, specifically Garmin. Garmin, has all the challenges we've described earlier. They're multi-cloud, they have devices on premises, they have the devices on Amazon, across even other public cloud implementations. They were struggling with a vast range of different vendors, one of which was actually Akamai, which is one of our direct competitors. We were able to onboard more than 1,000 Garmin applications onto the Cloudflare platform in less than a month. And this is due to our ease of use, due to our APIs. They now have gained control back over the network, and they're really pushing forward the way they deploy applications, and they protect them and they accelerate them on the internet. With that, I think I'm at time. So thank you very much for listening to me, and I will hand over to Sumo Logic.
Hey, Michael, before you hang it off, there was a question from the field, and I'll answer that question real quickly. We have a little more time, but does Cloudflare secure only web-based applications?
Sure. So that's a great question. Initially, when we first started as a company, yes, it was mainly a proxy for web traffic. Nowadays, though, we've actually expanded the proxy functionality, and we're able to support anything from layer 3 and above. So pretty much any protocol or any application, be it game servers, financial transaction servers, VPN traffic, we're able to support and protect all of that. So there's no exceptions left over that we cannot protect or accelerate nowadays.
Great, thank you. And attendees, please go ahead and use the Q&A box. We'd love to answer more questions in real time. Ben?
Great, thank you. So thanks everybody for coming to the webinar. We're obviously excited to spend this time with you. And so, I think to take a little break here. I did hear an interesting summary of an interview with some of the executives at Walmart, that there was a huge upsurge in clothing sales, but it turns out that it was overwhelmingly more tops than bottoms. I'll let you guys connect the dots, but it's creating a lot of interesting things for us and our customers. We actually have seen with our customers that they're actually in more need of the solution than ever because of they're so dependent on the digital properties. And we'll talk a little bit about that. But really happy to spend time with you today. I'm Ben Newton. I'm Director of Product Marketing at Sumo Logic, and I'm going to kind of give you an overview of what we do and kind of where we're coming from. As you said, feel free to put questions in the chat box or in the question Q&A box, and would love to answer those if we can. So, just kind of starting off, a lot of what we do at Sumo Logic is really wrapped into cloud migration. We obviously support customers wherever they are. We have on-premise cloud customers, but what we're seeing is that the cloud migration process is really driving a lot of the innovation in the industry right now. You know, wherever you are in that, whether you're kind of starting off in the beginning, more of a lift and shift kind of cloud migration, you can see some of our customers that are doing that. That's pushing you to think in new ways about your architecture. We're actually seeing evidence that during the pandemic right now, this is people that are in that state are actually increasing their cloud spend. And then at some point you make a top-down executive decision that you're really going to invest in this, and it's going to be a top priority for the company, and you move into what we call cloud first, and you really start to have these strategies that drive what you're going to do and how you're going to spend it. Now, this doesn't mean you're moving completely to the cloud. You know, that's I even heard the other day that Netflix literally just finished their cloud migration last year. So that tells you something. Even Amazon has on-premise facilities outside of AWS. So, you know, this is a process that companies will go to, and then there's kind of the nirvana to be cloud native and be completely focused there. But the bottom line is that this transition is driving innovation and data growth to the point where the data can almost seem unmanageable, and it's very hard to get the value out of the data that your applications and your infrastructure and your new cloud systems and these new SaaS apps that, for example, right now we just announced an offering around what we call work from home, focused on things like Zoom and VPN, like all these areas of our IT spend that just maybe didn't receive quite as much focus are now becoming completely central to business success, and that's now generating a lot of data. So, you know, it's a hard transition for companies to go through. So, and partly what's happening is that is generating both cultural and technical changes for companies today. So, one thing you see, and this is something I'm passionate about, is the kind of the culture changes going on. It's something that we could spend a whole hour just talking about that. But in short, the old model was siloed IT organizations where it's just centralized IT that's divided into very functional teams that really don't work together has become obsolete very fast. And so to really pursue these cloud-based, microservices-based, container-based technologies, you actually really need to move towards these more team-based, bottoms-up, collaborative models. DevOps, DevSecOps, site reliability, engineering, whatever it is you kind of subscribe to. The bottom line is the cultural change that you have to do, and that requires a common place to work together, because it's not good enough to have your own tools. You actually need to collaborate at every point in the process. And what's also happening is as you're expanding out to the cloud and you're expanding to these new SaaS apps, and like, for example, now that, all your employees are on Zoom, this actually increases the surface area of the threats you have to think about, that you have to protect, increases the perimeter, like basically your security perimeter. And because of that, it's so much more difficult to maintain compliance and maintain the vigilance that you need to protect your company's assets and to protect your employees and protect your users. And like I said, part of this is transitioning to these new stacks. And so, one of my favorite quotes about moving to microservices is that there was a tweet about this a few years ago, that we moved to microservices so that every outage was more like a murder mystery. And it honestly is totally true. Microservices provide enormous value for being able to scale quickly, and and anyone who does not have those right now, rather than digital services, is seeing that as so many of their customers are coming to them digitally. But that does add all this increased complexity and a lot of issues that you have to deal with as a company. And that is part of that is moving both to microservices architecture and moving from physical assets to these virtual assets in the cloud and moving to more of a hybrid model. But the bottom line is that this is so much more complicated. When I started out, you had a $20,000, $100,000 server that you racked and stacked, and you did some stuff to it and it was good to go. You saw blinking lights. That's just not where we're at now, right? So what does that mean for you when you're trying to use tools to give you the insights you need? Because fundamentally what's happening is you're generating this vast amount of data. You have all this new complexity, but you have a very hard time connecting the data that you have to the insights that you need. You need to be able to know if you're having security problems, if there's threats. You need to know if you're having downtime. And you basically have what we would call an intelligence gap. You have a gap between what you could know and what you actually do know. And why do you actually have that? Number one is because you're not getting all the data. Without going too much into the weeds, there's a lot of different types of data that you could be pulling in from a lot of different endpoints and a lot of different parts of your architecture that you're not now. And not only that, you're not only just pulling logs, but you're also pulling performance metrics, and you're pulling application performance data and things like that. And if you don't pull all that together, then how are you supposed to connect the dots and understand your murder mystery? Two is that it has to scale. And I think this is one of the things that a lot of companies are running into right now. I've gone shopping for things, that were essential, clearly, over the being at home with a family. And there's certain sites that clearly did not scale to meet this load. That when you move things digitally to the cloud, the scale challenges just completely change. And I'm going to talk to some customer use cases, later about that. But you have to be able to know that, for example, you have a campaign that you think is going to go one way and it ends up being 10x more successful than you think, and that generates an enormous amount of data and you can't keep up with it. So how do you do that? And related to that is going to be that the data is not aligned. Your licensing is not aligned to that. You can't have licensing that scales based on old server CPU models. So the bottom line is you have analytics that is siloed, you have data that is siloed, your licensing doesn't work, your security is not really integrated. So what do you really do about that? And that is where Sumo and our partners come in. And we're proud of the partner network that we built and all the systems that we can integrate in. And our fundamental mission in life is to help our customers cross that intelligence gap. So take all those things you see there on the left, to take the vast, complicated array of architectures that you have to deal with and that are really not optional now, that you have to monitor everything from Zoom to your VPNs and now your cloud environments. You're probably multi-cloud, or you're thinking about multi-cloud. You're having to deal with hybrid, both on-premise and cloud. You're having to deal with microservices and more traditional 3-tier architectures and things like that. And all this generates enormous amounts of data. And then how do you do that? And then we provide what we call the continuous intelligence platform. So it's this integrated platform that that we provide as a service that then provides all these pieces of functionality on top that can be used across your business. So being able to get the data in, then being able to allow you to monitor and visualize that in real time. Because again, you only have minutes or seconds sometimes to respond to customer issues and respond to threats. So you need to be able to see that streaming in real time. And you also want to be proactively notified about that. Again, you can't be behind the 8 ball. You have to be able to see things as they're coming and react very, very quickly, and potentially even be proactive by using machine learning to do that. And then once you actually get into the investigations, you need to be able to have the tools at your fingertips that allow you to do your murder mystery, to allow you to investigate and pull those threads together, and then be able to put things in place that are going to allow you to predict going forward. And fundamentally, you have to do that across your entire business. I'm going to talk about a customer use case where 90% of the business actually uses Sumo Logic data in some way or the other. So really, again, this is what crosses the intelligence gap from the left, where you have all this massive amount of data, to the people who actually need it. And it's all about enabling those people to enable the business. And we really divide what we offer into 3 big buckets. One is operational, which means keeping your site up, making sure that you're delivering the best possible customer experience to your customers, and that you are able to solve problems very quickly and reduce the mean time to repair, or however you measure it. Keep those key performance indicators. With security analytics, that means that you're going to be able to go and see those threats that are coming your way to be able to respond to them quickly, and do that in an integrated way that's integrated with all the rest of the data you see, and be able to track those issues very fast so that you can lock down, because it's inevitable that hackers are going to find a way in, but you need to be able to respond to that quickly and be able to solve those issues quickly. And also maintain compliance with things like PCI, HIPAA, whatever the things that you're being required to do from a regulatory perspective, being able to give that insight so you can give that to your auditors. And then finally, there's kind of an area around business analytics that's really emerging, where you can now take this data and enable different parts of the functions that you may not have thought could be enabled by this data. For example, your product management teams and your engineering teams, they can use it to better understand how the product's being used. I was a product manager for years at Sumo Logic. I actually used that to understand how my products were being used by our customers and how it could improve them. It could be used by marketing teams and sales teams. Our sales team actually uses the platform to understand how our customers are using the product. So across the business. And fundamentally, like we said, our goal is to do business a different way, to come at it from a different angle that provides you the analytics you need to cross that intelligence gap in a way that's cloud native, in a way that it scales to the cloud. So being able to get all the data you need, being able to scale no matter what. I'm going to talk to some really interesting scaling cases, but for example, we have a gaming company that those of you who had kids, it's very likely that one of your kids is playing this game that is literally doing orders of magnitude more data now than they were before. 2, 3, 4, 5x more data some days than they were doing before, even for a very popular game. Being able to seamlessly scale for that so they can continue to drive a great gaming experience for their users. Being able to do that in a way that's a flexible model for just like you would expect from AWS or GCP or Azure, being able to do that in a way that scales with your usage and the way you use it and give you a lot of flexibility about how you use it, getting that across teams, being able to use machine learning tools to be able to give you that visibility, and then do that with security built in from the very, very beginning. And to talk about some specific use cases, and then I'll hand it back off again. So we've been very proud. We've actually supported the last 2 Super Bowls. Whether they were exciting or not, this particular one, you can be the judge of whether it was exciting, but the data was exciting. That's what's important. So behind the scenes, we were supporting one of the largest streaming exercises for this type of media. It was huge, generating tens of terabytes just within a few hours, huge upsurge, and being able to do that to help them maintain the experience for people that had cut the cord and decided not to watch it on cable, and being able to stream that. And we were able to do that again this year. Kind of an operational model. Now on the security side, we're continuing to support customers kind of across the spectrum. Alaska Airlines, actually my preferred airline that I love to fly on. They've been a long-time customers of ours, and one of their use cases, and I actually use this for multiple use cases, but one of those was being able to consolidate their security, their SIM tools. So the security incident and event management, being able to consolidate those on one platform so they could have a single pane of glass point of view for their entire security team that was integrated with how their operations team thinks about it. And being able to take a massive amount of data and being able to process that in real time. Because again, when you're this kind of highly visible brand and people are depending on you day in and day out, you have to be able to respond to these things very quickly. And then finally, one of my favorite use cases with Samsung SmartThings. They've been a long-time customer of ours. And it's a case where there was just a natural organic growth of the usage at Samsung. They started out with an operations case, moved to things more around security. But fundamentally, if you don't know what SmartThings does, they actually have IoT devices in your home that can actually manage all sorts of things with home automation. It integrates with your Samsung phone. But the bottom line is that as they were expanding, they wanted to be able to have real-time insight into how their users were using the devices. So we were able to do that in a real-time fashion. And then once they saw that insight, they actually started providing that to teams outside of IT and security, even all the way up to the CTO. So the bottom line is they were able to drive more value for the business because they had this real-time insight and had that across the board. So with that, let me hand it back to Isaac, and we can handle any questions or anything else that comes up.
Great. Well, thank you, everyone. Ben and to the rest of the presenters. Great stories, great use cases, all related to modern cloud security solutions. Want to use the time to open the floor for any questions for any of the vendors. There's a Q&A box at the bottom of if you hover under your Zoom window, you'll be able to insert a couple of questions. Certainly, if you don't have any now, we can always come back to you offline. And we'll give a few seconds here to see if things come in. Meanwhile, just for certain housekeeping rules, our next steps for us will be following up separately to thank you for your time, be able to provide you some of the DoorDash codes. Let's see, one question just came in for Cloudflare. I'll go ahead and read that off. You mentioned Akamai as your direct competitor. How do you differentiate?
That's a very good question. Akamai has been around for a lot longer than we have. I actually very much respect Akamai as a company. They have a very strong product. But over the years, you know, they have acquired a lot of other companies, and they're starting to struggle a little as they build their platform when a lot of DevOps did not exist really, and they find themselves now in a very segmented space when it comes to their own infrastructure. So in terms of differentiator, first of all, the experience of onboarding onto Cloudflare is, in my opinion, a lot better. All the features we have integrate really well with each other. They're available from a single dashboard, and it works seamlessly. The other important thing to note is because Cloudflare operates the same stack everywhere, every POP is performing the same function. So when we say we provide DDoS mitigation, our entire network is doing DDoS mitigation. It's not just a number or a subset of our infrastructure that is performing a single function. And I think that's also very important to mention. And then finally, our API integrations and our ability to build on top of Cloudflare, I think is unmatched, including against Akamai. Those are three of the many things I would mention in that regard.
Great. Thank you, Michael. Any questions for Sumo or BitGlass? Just give a few seconds here. Any funny jokes? Let's see. All right, I'll give another 30 seconds and I'll wrap up, but certainly we'll follow up with a point of contact from each of our vendors and myself or one of your client managers at Optiv, and we're happy to continue talking. Another question here is what piece of the CASB architecture does BitGlass do best?
Yeah, great question. So like I was mentioning earlier, you want to make sure that you pick a CASB that has all three of those deployment options. So the API, the forward proxy, and the reverse proxy. BitGlass is bread and butter, if you will, even though we are a true multi-mode CASB that does all three, is our reverse proxy. That's what lets us get in line and secure any device. And so it's a really powerful solution and something that I think is the hardest one to do in a robust fashion from an engineering perspective. And that's because of some patented AJAX VM technology that we have that would take a little bit of time to get into, but just know that, yeah, the reverse proxy is the thing that I think really sets us apart.
Great, thanks, Jacob. Another question came in. What level of coverage of SaaS apps does BitGlass have compared to competitors?
Yeah, another good question. So I think that the main thing to keep in mind is how you're securing these applications from that architecture that I mentioned earlier. So because BitGlass is multi-mode in the fullest sense, we can secure any application. So it doesn't have to have an API. It doesn't have to, be just one of the major SaaS applications. We can proxy traffic to and from any app. And where there are APIs on applications, we can dig a little bit deeper with some of the visibility and control over data at rest type stuff. So yeah, any SaaS app, any custom app built on any IaaS platform, whether that's AWS, GCP, Azure, as well as any on-prem app through things like ZTNA. So good mix there for you. You're still muted there, Isaac.
I was going to say we still have about 5 minutes, and I want to keep everyone from lunch, but any other questions that we can talk about or field answer for you? Give about 15, 20 seconds. All right. All right, well, great. Well, I think I'll go ahead and wrap up the call today. Again, any questions, certainly we'll respond back off in an offline email as a thank you and a follow-up. Michael, Ben, Jacob, thank you so much for your time. And everyone, be safe out there, and we'll talk to you soon.
Thank you. Bye-bye. Have a good one.
Thank you.
Thanks.